So everyone should see my Google Chrome in front of them. If you can't see, let me know and we'll figure it out, but I think pretty much everyone should be able to see it. So let's see, what are we talking about this week? We are talking about decision making in Python. And what do we use to make decisions with Python? Well, first of all, if I'm talking about making a decision and I'm, saying, do I want hot dogs or hamburgers? Well, that would be the way I would ask the question in English. Do you want a hot dog or do you want a hamburger? However, that's not the way in which we can ask a question to Python, because Python has a very limited language. There's very little that it knows, and it only knows what we tell it, and there is only a very certain way in which we can ask a question to Python and have Python answer that question to us, back to us. And that is the use of a branch. And basically what you can do is you can think of a branch as just that. You've got a branch, and you've got other little branches coming off of it. And a branch is just saying, go down this section of code or go down that section of code, rather than what we have been doing, which is one step after the other. And I'm going to bring up PyCharm, and we're going to do a few things in the debugger so you can see what I mean by it following one branch of the code as opposed to another branch of the code. But let's get started with syntax. How in the world do I ask a question to Python? Well, I do that, I'm trying to find. I do that by using an if-else statement. If a statement starts with the word if, that means I'm asking a question to Python. If is a keyword, it is a specific word, and it is always meant to make a determination of what am I supposed to do. Now, Python can only have two answers. One of two answers if you are asking it a question. It will come back with true or false. Like I said, Python is very simplistic. So we have to be careful what and how we answer the questions, ask the questions for an answer. There are actually three different keywords associated with branching: if, elif, or else. Now this E-L-S-E, if here, is not right. It's elif. So I think what I'm going to do is, instead of scrolling through that, I'm going to open up my PyCharm. I'm going to create a new Python file. I'm just going to say simple branch. So I've got this thing called simple branching. Hold on a second. I think I have to add Python to it. Click the button. Okay, Python. Okay. Script path, parameters, template. I don't know why it doesn't do this automatically for me anymore. Python interpreter, that's what I want. Okay. I don't know why the new PyCharm doesn't do that automatically. So this is just an example of branching. So the first thing I'm going to do is I'm going to have a keyword if. Actually, let me make this a little bit bigger so it's easier for people to see. If is a keyword.
I have a question.
Absolutely.
Don't you need to set the path on the on that little where it says unnamed up there?
Oh, maybe I do. Let's see.
I think you go to edit configurations
Oh, I
and
just need to
then
give it.
the script path. You have to name it, and then I believe the script path needs to be set to that file.
Okay.
I pressed the I think you pressed the folder on the right there.
Thank you.
Yeah, no problem.
PyCharm that I used until I updated to Big Sur, I never had to do this. It did it all for me automatically.
Yeah, it was a little confusing at first.
Yeah, when I was really disappointed when I upgraded, when I had to upgrade to this version of PyCharm because I felt like they went back in time a little bit, and I've been using a different version of PyCharm at work. So I'm doing all this stuff on PyCharm at work, and then I sit here and I completely forget that I need to actually go and modify things that I didn't have to modify.
You have to click the down arrow and then select the branch.
Okay.
Yeah, I think you have to. It should be there. Once you,
yeah.
Oh, you named it module 2. Okay.
I just named it module 2.
Okay, perfect.
Yeah. Thank you very much for reminding me of that.
No problem. Yeah, every file we create, we have to do that.
Yeah, and it's irritating because you didn't have to used to do that in Python.
I wonder if there's some setting we don't know about that'll just default it that way.
I have looked, and I've also done some Google research, and I haven't been able to find that. In the old PyCharm, you could just go out and do a site setting for everything to always use the same version of Python, and it would automatically populate everything. And the only thing that you would have to do then is add your parameters that you needed to pass in. But this PyCharm is different. Anyway, thank you, by the way, for that. We're just going to do some really simple branching. And I'm going to say if my int is greater than 3, and then I'm going to say now this is very simplistic and just off the top of my head. But what do I have here? First of all, we all know what this is. This is a variable called myInt. I know it's a variable because it's on the left-hand side of a single equal sign, and I have the value, which is 2. Now, tonight, we're going to learn about double equal signs, so I don't want them to confuse you. But for right now, this is just an example of what branching is. Every branch that you create, every series of decisions that you create always has to start with an if. You can never start with an else because you will get a syntax error. Python expects if you are only ever going to ask a single question, that single question is going to start with the word if. PyCharm is nice because you'll notice that if is in orange. And in my PyCharm and in the standard PyCharm that you will come with, keywords are orange. A value is blue. And strings are green. But anyway, so I have this thing that says if, and then I have my int greater than 3. Well, what in the world am I saying here? What I am asking PyCharm, or Python, is if the value of my int is greater than 3. Or actually, let me rephrase this. I'm going to say, is the value, now let me do this again. Sorry about that. The value of my int is greater than 3, true or false. That's basically how you need to read that. Okay? Python can only answer with true or false. true or false. They're Booleans, there's one or the other. So when I look at line 5, this is really what I am saying to Python. I'm stating that the value of my int is greater than 3, and I'm asking Python to give me back a true or false. If it gives me back a true, then I'm going to hit line 6. If it doesn't give me back a true, i.e. it gives me false, then I'm going to end up at line 8. And I'm ending up at line 8 because there's an else statement. And an else says, okay, the if statement was not true. So if the if statement wasn't true, then hey, here you do what's in my block. Now that's a new word, block, because what we have under if, starting at line 6, is a code block, and starting at line 8 is another code block. So what's a code block? Well, a code block, kind of like a little mini program. And only that code block will only run if this is true. Or it will run if nothing else can. So a code block is a very important thing. And one of the reasons it's so important is because we want to start thinking in a modular fashion. Modular programming, whether it be object-oriented or procedural, but modular thinking in our programming is really what we need to do. We need to do that because of something called reusability. We want our code to be as reusable as possible. So we're going to start looking at code blocks. And in this we just kind of introduce them when we're doing if-else statements. When we get into looping, we're going to be using code blocks all the time. And when we get into functions, we're going to basically be writing named code blocks. So it's an important concept to begin the process of understanding. So I said we were going to use the debugger, and we are. So one of the best ways I know of to show you what happens with if-else statements is to run it in the debugger. So what does the debugger do? I love debuggers, by the way. I think debuggers were some of the greatest inventions in programming ever. Because what I can do is I can look at where I'm actually at in the code. So first of all, there's this red dot. That red dot is a breakpoint. I have told Python by setting a breakpoint that I want it to stop here. If it reaches this line of code, just stop. Don't do anything. Don't execute the line of code. Just stop on that line of code because I want to look at what's going on. And this is the first line of code, so nothing's going on yet. And then I have these commands down here. Well, first of all, I have the console. Right now, I'm at the Debugger tab. There's the console, which basically tells me I'm connected to the debugger. And then there's these other, there are these other commands. Now, this is show execution point, and that's where we are. We have the ability to step over a line of code. We have the ability to step into, and we'll use step into when we start creating our own functions. We have step into my code, and I've never used that. And we have step out, and we'll use that when we're in functions as well. But for right now, I'm going to step over. So what happens when I step over? Well, when I step over, you will notice that the variables pane here in PyCharm has changed, and it says my int equals 2, and then it's got this int here in curly braces, and that just tells me the type. Also in PyCharm, what you see is my int :2. Now this right here is not actually a line of code. This is just something that it's like a heads-up display that PyCharm gives you to tell you what the value of that variable is at any given moment in time. So the value of that variable right now is 2. Might change later, but for right now, on that line of code, it's 2. The blue line of code is now on 5, and that's because that's where I am sitting. Okay, I am sitting at just, can you guys hold on for just a second? Sorry. Thank you. So I'm now sitting on if my int is greater than 3. So what's going to happen here? Well, what is going to happen is Python is going to say, okay, I have this variable myInt. MyInt has a value. The value of myInt is 2, so is 2 greater than 3? Or the way I said it before is the value of 2 is greater than 3. Well, that's false. So when I step over this code, I'm going to end up down here. You'll notice I did not make it to line 6. I did not make it to line 6 because this statement did not evaluate to true. It evaluated to false. So here I'm just going to print nope, and I'm done. So there we have the nope in the console, and I'm done. So that's what the debugger is. And by the way, you can set a breakpoint or unset a breakpoint just by clicking a line in PyCharm. It's very handy. That's what the debugger is, and we're going to use that a little bit more. And that's the basis of what branching is. Now, if I change the value of myInt to 4, what do we think is going to happen? Well, what I think is going to happen is I'm going to end up here at line 6, and I won't ever hit line 8, because these are mutually exclusive. Line 6 and line 8, the way this is written, are mutually exclusive, which means I can never have both. I can only have one. The previous, when myInt was 2, I got to line 8, but I never got to line 6. Now I'm going to get to line 6. So I'm going to walk through in the debugger again. I'm going to do a little quicker this time. I'm just going to step over. Now, myInt is 4, so I'm going to say the value of 4 is greater than 3. That's a true statement. So I'm going to print in the big time, and then the program ends. You'll notice I never made it to 8. I never made it to 8 because these are mutually exclusive. This, line 6, is inside the if branch, and 8 is inside the else branch, and never the twain shall meet. So this can be a difficult concept for students to get the first time out when they've never had exposure to any other form of programming. And a lot of times that's because we think of asking a question in a very different way than a computer can accept a question. So we really have to go back to basics and almost dumb down how we would ask a question so that we can get the computer to understand it. So I know I went a little off script with the zyBooks stuff, but I really wanted to introduce these things so that I think we have a better framework to talk about the rest of the branching. And oh, by the way, sorry about that. I'm going to show you just a couple other things while we're here really quick. There's this very specific syntax here, all right? It begins with an if. The little question part goes here. And this can become more complex, but for right now, that's all it is. And then I have this colon. This colon can make people very unhappy because a lot of students forget it the first time out. They don't understand why their program won't run or won't compile. So right now, everything is working. However, if I remove this colon and I run this, I get this. The value of myInt is, okay, syntax error, invalid syntax. That is because that colon is gone. All of that happened because I removed the colon. If you get a syntax error, invalid syntax, and there's a good possibility that it will not happen on this line of code. I'll show you when we do another example that, it might say that line 6 has the invalid syntax. However, that's not the case. Line 6 is just fine. It's line 5 that had the invalid syntax. So this is just something to remember, and the same here with the else. Just something to remember that you need that colon. So, let's see. Does anybody ask any questions? No. Okay. Can you hear me? Can everyone hear me? Okay. Everyone that's on can hear me. I was just looking at the chat, and there were some people who couldn't hear me earlier. So I wanted to make sure everyone could hear me. And that I wasn't, talking like Charlie Brown's teacher. Okay. So those are if-else statements. Let's see. Let us go and do a challenge. We're going to do a challenge together. I think that's important. So this is the basic if-else expression. And this time, I don't usually go through the whole thing. I let you guys figure them out. But this time, when we start to get into some more of the complex stuff, I'd like to go through at least a challenge completely so you can see what is supposed to happen. And also because I've noticed that with some of the lab activities, students are saying, well, it works in debug, but not when I submit it. And I think that's because we're not testing edge conditions. So I want to talk about testing edge conditions when we get to maybe a lab. So this is 3.2.2. So I'm going to say new Python file. Okay. And module 2. I'll just change this to challenge, and then we should be good. So what is this asking us to do right now? It's saying write an expression that causes the following code to print 18 or less if the value of the user's age is 18 or less. Write only the expression. Okay. So what they're asking is, let's see, we'll just put this here really quick. Okay. So what they want you to do is
I have a quick question.
Absolutely.
That integer input, integer is created to be able to use it in formulas, right?
Say that again.
So because sometimes how sometimes you put like input, just input by itself with the semicolons around it, and sometimes you do integer like int input, and the int input is so that you could use it like in calculations, like equals this minus 10 or something.
Yes. So if I can just change this really quick and show you an example. So if I say var1 equals input, is this a string? Okay, actually, let's do the number 1, and then I'm going to say var2 is int input, oops, sorry. Oops, I can't type right now. Okay, so I have var1 and var2, and I think this will work. Type var1, var2. Whoops, not fair, var. What else? var1 is I apologize. I always have this trouble when it gets to the thing. All right. And then the type of var2 is so let me, hold on. I didn't want to do that. Input and then input. Ignore what I did the first time. This is better. So I'm going to run this, and I'm just going to put in one. Whoops, I'm running the wrong thing. Hold on. Edit. Simple branch. Okay. Run this. Okay. So I'm going to put in 1 and 1. And it says the type of var1 is, oh, that's why. My apologies. It's a class, and format wasn't changing the format. Okay. Oh, my bad. Again, typing at night is not my forte. So, okay, format, stir, type. There we go. So what I was doing here is I was just trying to make it clear as to what was what. So when I am running this, I'm just going to type in 1 and 1, okay? So the format, it doesn't like format. So I'm just going to do this. I'm not going to mess around with trying to figure out how to get the class name right now. Print. Okay, so just to let you know, in Python there is a function called type. Type will tell you what kind of a variable you're looking at. Is it a string? Is it an int? Is it a float? Is it a Boolean? Type will tell you that. So even though my dot format wasn't working, if I put in 1 for the first variable, 1 for the second variable, I get the type of var1 is stir and the type of var2 is int. The difference and the only difference is this int right here. When I enclose the input in an int, it will convert it automatically for me. When I enclose anything in an int, it's going to try and convert that for me. So does that answer your question?
Yeah, and then the string is like what's the so integer, int is integer, right? And str is string?
Yes.
Okay.
So str is always string in Python. Int is always an integer. Float is always a float. And bool is a Boolean. And we're just learning about Booleans tonight because it's the new type that we deal with when we're dealing with branching.
And strings are what we would put into a list, right?
Or ints. You can put anything into a list.
Okay.
Yeah, when we get to data collections, when we actually do a deep dive into data collections, you can put anything in a list. You can put a list inside of a list, or dictionary inside of a list. You can create all kinds of data structures in Python because it's so malleable when it comes to the things you can put in a list. You can put in the same list, you can have strings and floats and ints and booleans and other lists. So does that help answer your question?
Yeah, that does. Thank you. I appreciate it.
Oh, not a problem. If you have you or anybody else has any more questions, let me know. So we're going to run through challenge 3.2.2. And basically, it's just looking for what the solution is here. So if I go back to this, and it says, write the expression that will cause the following code to print 18 or less if the value of the user age is 18 or less. So for us, we have, oh, hold on, before I forget this. There we go. So I'm going to input a user age, and I have this kind of non-existent if statement here that we want to make work. So if user age is 18 or less, I want to print 18 or less. Otherwise, I want to print over 18. So I'm going to ask the question, if user age is less than 19, then it's going to print 18 or less. Otherwise, it's going to print over 18. Okay? Now, this is another way to ask that question, but this will work for right now. So when I'm looking at this, what I'm saying is the value of user age is greater than 18 or less. Actually, it's greater than or 18. Greater than 18, period. True or false is greater than 18. Okay, so, oh, wait a minute. 18 is less than 18, my bad. Less than 18. 19. I was right the first time. I apologize for being confusing. So, if user age is less than 19, and what I'm really saying is the value of user age is less than 19, true or false. And if I'm correct, then it's going to print out 18 or less. If that's not, if this statement is true, it's going to print out 18 or less. And if it's not, it's going to print out over 18. So let's run this and try it a couple different ways. So first of all, I'm going to put in 1. And that's 18 or less. That was easy. So let's try again. And we're going to say 18. And I'm still 18 or less, so that was correct. Then I'm going to put in 19, and I'm over 18. And then I'll put in an outlier, let's say 27, and I'm over 18. So we have 2 branches. We have the first branch, which is an if statement, and the second branch, which is an else, which is basically if it doesn't turn out to be true, then it's false, so do this. So that's what challenge 3.2.2 looks like. And I'm doing this one for you so you have a better idea of how to go about thinking through these problems. So let's keep going in zyBooks unless anybody has any questions. Are there any? Don't seem to be any in the chats. Okay.
Yeah, we had a problem like that in Module 2, and it was like a little confusing, but I ended up figuring it out. It was just like, I think it was the name input where it wanted to ask like for the full name.
Yes.
And then, but some of them were, you know, 3 names, like first, middle, and last, and then the other was just first and last. And then I think I had to basically len the input to get a count, and then go off of len to create the if.
Yeah, and unfortunately, and the school's been notified about that, that, in my view, is an unfair lab or an unfair challenge because you're having to do something you haven't been taught. So
that's the hard part about it is I was trying to look back in the module of how to like figure it out, and it wasn't anywhere in the lessons.
That's because yeah, and the school's been notified, and I mitigate that for my class. I can't tell you what other professors do, but I mitigate that one for my section because it's completely unfair. You haven't learned about branching, but yet the solution to that requires that you use branching, and that's just ridiculous. So you should pat yourself on the back for actually having figured that out. Now, for any of the people in my class, I hope you didn't spend a lot of hours on it. Reach out to me if something like that's happening, and we'll figure out a way to make it better. So we have what are called multi-branch if-else statements, and this is where we get into an elif scenario. So we have this other keyword that is elif. So you have your first question, and then you're going to ask another question. And then eventually you're going to run out of questions and you're going to have an else. So I'll show you how the elif works in a minute. But the other thing I wanted to talk about was this equality operator. Remember when I said at the very beginning that when I said, you know, a variable is on the left-hand side of a single equal sign, and we were going to learn about double equals tonight? Well, this is a double equal sign. A double equal sign is used in branching, and it is, they call it the equality operator. I call it an equivalence operator, because what you are doing when you use the double equal sign is you are saying, are these two the same thing? Is what's on the left-hand side of the double equal sign the same thing as what's on the right-hand side of the double equal sign? And if that is a true statement, then you are true, and if not, you keep on going. So let's go down and look at 3.2.4. And we'll do some of this. Maybe we'll do all of it, I don't know. Okay. 3.2.4. Okay, so what are they, and if, this is when I start to do a little bit less theory. So if I'm not doing enough theory, you guys reach out and let me know, and we can go back through zyBooks and do more theory. But I think when we're starting to get into branching and then for loops, what I have found in the past is that it's easier for students to learn if we're actually actively working through a few problems. So that's kind of what I'm using the time more for right now. So, okay, let me... So let's see. What this is just telling us is this is just the problem statement. So write an if-else statement with multiple branches. This is important. If the year is 2101 or later, print distant future without quotes. Otherwise, if the year is 2001, print 21st century. Otherwise, if the year is 1901 or greater, print 20th century. Else, 1900 or earlier, print long ago. Okay, so we're just going to have to input the year. So I'm just going to say year equals and input the year. So now let's talk about the construction of this, because there's a lot going on here. There's a lot of moving pieces. So if the year is 2001 or later, print distant future. So that's going to be the first thing. So we're going to ask a question, and we're going to use year on the left-hand side. Year is the input value, it's going to have some value, it's going to have been turned into an integer. So I want to compare year to 2001. Now this isn't exactly correct. Print, what do they want? Distant future. So we're just going to try this right here. This isn't the whole solution, but I want to kind of demonstrate how to build things in baby steps and how to test while you're going. You don't have to write a huge long program. This is also going to help you when you start writing your game, because you're not going to be able to write your entire game. Well, maybe you will, but I don't know very many programmers who write a whole big long program and it works perfectly. So my suggestion is baby steps, and this is how I code. I was writing a Python script to use text-to-speech with IBM Watson because they have a really great Python interface and we needed it for something. I didn't start out by writing a big program. I started out by seeing if I could connect to Watson. And then once I connected to Watson reliably, I started figuring out, okay, how do I get voices? Okay, let's go get voices. And I just stepped through, and in a day I had a pretty good program. Had I attempted to write all of that at once, I would probably still be debugging it. So this is kind of a methodology to help you program better and become less frustrated. So the first thing I'm going to do, and like I said, line 9 isn't quite right, is I'm going to run, have I changed this yet? No. So I'm going to make this, and I'm going to change it to that, and I'm going to run this, okay? And I'm going to input 202101, and it didn't do anything. Well, let's go back and read this. If the year is 2101 or later. So this obviously isn't right, because I said, is the year later or greater than 2101? So in this case, I want to use a greater than or equal to sign. So we haven't dealt with this type of Boolean operator before. And there is in zyBooks a whole, just talking about the different Boolean operators. So this is a Boolean operator that's read greater than or equal to. So what I'm saying here is the year is greater than or equal to 2101, true or false. And so I'm going to run it again, and I'm going to put the year in as 2101, and I now get distant future, just because I added that equal sign. And I know that I have now met the first condition, okay? If the year is 2101 or later, print distant future. I've figured that one out, okay? Now it says otherwise, whoops. Let me undo that. Okay. Now it says otherwise, if year is 2001 or greater, print 21st century. So we've dealt with if and else, but this time we're going to deal with elif. That's a new one. And this is going to allow us to ask a second question. And our second question is going to be about year, because this is really the subject of the question. Is this variable year? So I'm going to say else if year, and it says year is 2101 or greater, is greater than or equal, because we already found out that that greater than or equal was important. I'm going to print 21st century. Okay, so now let's test our code again. So I'm going to make sure I didn't mess up the first one. I'm going to print 2101. And that's good. Let's just give it, 2300. Still good. Okay, so I put different inputs in to check my code. So now I'm going to say 2001 is the 21st century. So now let's try 2002. It's still the 21st century, and I'm still meeting this requirement. So what if I put in 2000? I get absolutely nothing, which at this particular moment is what I should get. So now it says, otherwise, if the year is 1901 or greater, print 20th century. So we're going to do that. And again, year is the same subject. And that's when you want to use the if, else, is because you've got the same subject matter and you want to do something different based on the value. So in this case, if it's 1901 or greater, not if year is greater than or equal to 1901, then I'm going to print 20th century. And now I'm going to run my tests again. I'm going to say 2101. Great, nothing has changed. I'm going to say 2001. Perfect. I'm going to say 2000. Let's see what happens. 2000, it's now the 20th century because it's if the year is greater than or equal to 1901, and 2000 is greater than 1901. However, it's less than 2001. If is what's happening, and we'll walk through this in a debugger in just a second, and then I'll show you what's happening. Otherwise, so that's else, print long ago. Okay, so now let's walk through this in the debugger. So I'm going to hit the debugger up here, and I've got a breakpoint, and I see the console, and I'm going to type in 1900 because I want to walk through all of this. So now I'm going to continue. Oh, stop and rerun. My bad. Type in the year. Okay, 1900. Oh, my bad. Let's do this again. Okay, don't worry about that. It was because I interrupted it. Okay, so I'm there at the console. I'm going to print 1900. I'm going to step over. Oh, now I'm going to step over. Enter. Okay, so here we have years 1900. Okay, I can go to the debugger. I can see that my year is 1900 right here. So let's ask ourselves what's going to happen. Year is 1900. So 1900 is greater than or equal to 2101. True or false? That is false. And when I step over this, I'm not going to hit line 10 because that was false. So the next thing is 1900 is greater than or equal to 2001. True or false? That's false. So I am not going to get to line 12. And now I'm going to talk again, and I'm going to say 1900 is greater than or equal to 1901. That is in fact false. So I'm going to come all the way down here to print long ago. Oops, sorry. And I'm just going to continue. So we're going to do this one more time, and I'm going to put in a different date, and we're going to watch it stop at a different place, and then we'll move on. Because there's a couple more things. We're getting close, and there's a couple more things I want to talk about tonight. So let's step over that. We're in the console. Now I'm going to put 2021. Okay? Hit the Enter key. So year is now 2021. Let's see. What's everyone saying in chat? Yes. Well, after this, we will go in, Chris, and we'll just look at the third lab. After I do a couple more, I want to hit a couple more points. So the year is 2021. So my statement is going to be 2021 is greater than or equal to 2101. That's false. I'm not going to hit. So 2021 is greater than or equal to 2001. Yes, that's true. So I'm going to hit line 12, and then the program's going to end. So I'm pretty sure my program is working. So now let's go back and more else if. That's not what I want to do. Equality, and here are all the relational operators, equality and relational operators. So you have, you know, a double equal sign or not and an equal sign. So this means is equivalent, this means is not equivalent. These are all the greater than, less than, greater than, or equal, which we just used. I want to go into compound. Okay, we'll keep going. Boolean operators and expressions. Okay.
So I got a question. So on those elif inputs there, basically you always start with if, and elif is just always in the the body, in the middle of it, and else is like your ending statement, I guess.
Absolutely. You always have to start with an if statement. You don't have to have elif or else. None of that has to be there. But if you're asking a question, the if statement does. You can never have an elif. Sorry, go ahead.
So you're going to say probably that you can never have an elif without an if statement.
You are absolutely correct. Good job.
And then the other thing I was going to ask is, and you can't have multiple ifs, right? So you have to have if, elif, and then else.
You can have multiple ifs. You can have as many if statements as you want. But
okay.
Only if, elif, and else are mutually exclusive. So I could do if year 2020 print it's over. Okay? So I could do that. That's completely legal. And if I run this code, I'm going to put in 2020, and I'm going to continue. Wait a minute. Am I in debug? Oh, I have to hit the enter key. Okay. So I get 21st century and happy it's over. So the year was 2020. It came down here. It's greater than 2001. It printed 21st century. And then I decided I wanted to do something if the year was exactly 2020.
Got it.
So you can have as many if statements as you want, about as many different things as you like. There is no limit in a program.
And then the elif has to follow an if, though.
An elif or an else. If you have an elif, it has to follow an if, but you don't have to have an elif. An else can follow an if. If you have an elif, it cannot follow an else. An else has to follow an elif, because an else is like the bottom of the bucket.
It's like an introduction statement, body, and your concluding statement, right?
Yes, that's a very good way to put it.
Just for memorization.
Yes, that's a very good way to put it.
Okay. And then so you can't, it's basically your whole essay per se.
Yeah.
And, okay, that makes sense. You could have as many as, all right, I got it. Thank you.
No problem. It's always good to get these things down now because you're going to need these for your final project. So you're going to need loops, you're going to need if statements, you're going to need functions, you're going to need all of this stuff when it comes to the final project. And by the way, if you guys are starting to have questions about your projects, what your final project is going to be, kind of how to do that, bring them to class and we will talk through them. I got a little bit too much trouble last semester going through too much of the project, but what I will be doing as we get closer to the project is one of the classes we're going to be going over something that is similar to the project but not the same as the project. So, Boolean operators, and, or, and not. So we're now going to basically create combined statements. An and says both things are true or false, or all things are true. Or says any, and not says the opposite. So red. And let's actually go look at Lab 3 because that might be a good way to look at that. So this is exact change, is that right? Okay, write a program with total change amount as integer input and output the change using the fewest coins, one coin type per line. The coin types are dollars, quarters, dimes, nickels, and pennies. Use singular and plural coin names as appropriate, like 1 penny versus 2 pennies. So if, this is where you have to use the floor operator. So if the input is 45, you have 1 quarter and 2 dimes. Yeah, this is where we use the floor operator. Let's look that up. This is one of those operators that not many of the other languages have. And I always forget how to use it because I don't use it in my daily life. Okay. Okay, so the floor operator says how many times will it go into that? So if you look at this example, you have 50 divided by 2. That gives you an answer of 2.5. Makes perfect sense. Then you have 50 and this double divide. That double divides a floor operator. And it says 2, and you get a 2 answer. So that means that it's how many times, it's like a modular operator almost. How many times can 2 go into 5 without having, and still having a whole number? And so that is 2. So that's where the floor operator comes in on this one. And we'll do just a little bit. I won't do the whole thing. So this is Lab 3.13. New Python file, Lab 3.13. Okay. So basically what we're going to do here is we're going to use the floor operator and write a program with a total change amount as an integer input and output the change using the fewest coins possible. So okay. I'm just going to make this readable. The coin types are dollars, quarters, dimes, nickels, and pennies. Use singular and plural coin names as appropriate. I'll let you guys do that. So, input, coins, input, this is going to be int, because we're not going to deal with floats here. We're just dealing with int. And so, this is just going to be me. Some of this you won't want to leave in the program, but when I am writing a program and I'm debugging it, I'm going to put a lot of print statements in and then take them out later. So first, well, let's start with the greatest amount. So I want to know how many dollars my coins make up. So I'm going to say 100, because that's 100 pennies. Okay. Let me change this. Okay, so that's what we're going to do. So right now I'm just inputting coins, and I'm going to print the coins, and I'm going to see the result of 100, which is pennies, because pennies is my lowest denomination, divided by coins, or sorry, with the floor of coins. So let me run it, and I'm going to enter 100, and I get the answer 1, which is what I would expect. So I'm going to run it again, and I'm going to put in 45, and I get 2. So maybe that's not right. Coins divided by 100. Maybe that's it. For 100. Let's give this a try again. Okay. And what I did was I just found out that there was a logic error in my code because I knew that 45 didn't go into 100 twice. Okay. So this is the correct calculation. Enter the amount 45. I said 45. 100 goes into 45 0 times, so I have no dollars. Okay, so now let's do it again. And if I put in the amount of 200 pennies, I get 2. So this calculation, I'm pretty sure, is correct. So I have a result of something. So my result, if so I'm going to say if result is greater than 0, print dollars I'm not sure exactly what they want the output to be. And then I'm going to have result equals result wait a minute, equals coin oh, because we only want the coins that are left. Coins is coins minus result times 100. So now we're going to get the new coin. And then we're going to do it again. So the first time we go through is, and now we can probably do it like this. So I don't need this line here. So if coins, floor, if you're doing a floor operator on coins and it's greater than 0, you're going to print the number of dollars as, let's see, as okay, and then this is going to be, yep, somebody asked me a question. Okay, I'm just going to do one more if on this one, and then we'll go over lab 2. So I'm going to have coins equal coins minus, my bad, minus coins of 100 times 100. Yes, that will be right. So this will give us the remainder, and then we would do it again. So we are going to do if coin floor of, let's see, quarters, 25, And then I'm just going to put do the rest here. So you guys can now, you've seen how I did the dollars. So this is for dollars. And this is for quarters. So you guys can work on the rest of this lab for the rest of quarters, dimes, nickels, and pennies. But this is what you do. This is the floor operator, and you're going to want to get rid of that print statement. So let me then look at lab 2. Okay. Oh, no problem. Okay. Was the stuff for lab 3 in the module? Not sure where it went over. I have a question on the input. So let me answer this. The stuff for lab 3 is almost in the module. It doesn't talk about the floor operator. The floor operator is briefly mentioned in the first module. But frankly, if I hadn't been going through this for a while, I wouldn't have remembered that I needed to use the floor operator. So you guys can get the rest of the if statements. I think that you're fine here. You do not want to use elif. You just simply want to use separate if statements. And this is the part that gets most people, is that special floor operator. So technically, the information is in zyBooks, but it's not in all the same place. So let me go to the next question. We'll go over lab 2 in just a moment. And you're welcome. I don't have a problem. I'm glad that this is helpful. I have a question on the input. My input never works in zyBooks. Yeah. zyBooks is extraordinarily picky about inputs. And unfortunately, because I share my zyBooks with all of the other teachers, I can't play with this. But the input, oftentimes in zyBooks, you don't want anything like this in the input. Get rid of that. zyBooks can be really funny about that. So what I have found and what other students have told me is that if you don't put anything in between the parentheses for the input, then you're probably okay and your inputs will work in zyBooks. If you have anything in between those parentheses for the input, zyBooks may not work correctly. So give that a try, Luke, and if it doesn't work, send me your code, and you and I can take a look at it together. Does that work? Okay. So how about this, Luke? Let's take a look. We're going to take this off of the free conference call. I'd like you to email me, because if it's not working, what we may do is set up like a Teams or a Zoom session where I can actually reach out and see what you're doing, because I can't play with zyBooks because all of the teachers share the same zyBooks. So if you wouldn't mind sending me your code and reaching out to me after this, you and I can go look at your specific issue, if that's okay. Okay, no problem. So now we're going to go off and look at lab 2. So let's go back to zyBooks. I'm sorry this is running late. If anybody needs to get off the call, that's completely okay. Okay, so it says write a program that takes a date as input and output the date's season. The input is a string to represent the month and an int to represent the day. So if the input is April 11, the output is spring. If the input, check the input string is a valid and actual month and day. So if the input is blue 65, then you're going to get invalid. And then here are the ranges. Now we won't go through all of the ranges, but we'll start you out on this like we did on lab 3. So let me create a new file. And this is going to be Python file. Okay, lab 3.12. Okay, change the module. And this is 3.12. Okay, so let's just copy some stuff in here so that I have a reference. Okay. And then I'm going to put the season stuff in here too, just so I have it in front of me. Okay. So what do we have to do? Well, we have two basic requirements. One is that I can't put in anything weird. And the second is that I can tell you when spring is or when fall is. So what I want to do is, the first thing I'm going to do is I'm going to validate. Well, first thing I'm going to do is I'm going to say month equals input. Please input the month. And then I'm going to say day equals so the first thing I'm going to do is validate. Now this is something common that you're going to want to do in normal daily life and in your project. Because some teachers will say, okay, can I put something wrong in and let's see what happens. So the first thing I'm going to do is I'm going to say if month is not January and month is not February and month is not, I'm not going to do all of these, but you get where I'm coming from. Okay? So if and this is a compound statement, so this is something we were talking about a little bit ago. I have a month that I'm going to put in, and I'm going to say if it's not January, and it's not February, and it's not March. And what you guys need to do okay, what was the comment? By putting commas in each of the questions. Can you use the same is not, could you use the same is not for all 12 months? No, you can't. Commas don't work here. You have to, commas don't work there. You have to have this like that. Now, the other thing you can do, we haven't really gone over lists yet, but if I were writing this in person, I would have months equal and then dot, dot, dot for the rest of them. And what I would say is, let me comment this out. I would say is if month not in months. And that would take care of that. Okay? So if I had a list with all of the months in it, and I said if month not in months, then it gets everything. It will automatically, Python is great about that. It will automatically go out and check every element in the list for me, and if the value of month is not in that list, it's going to say, oh, sorry, it's not in the list. So if I were doing this in real life, that's what I would do. but we don't. We have been introduced to lists, but we haven't done a deep dive in them. Hello, what's going on? Okay, so this is if you're comfortable doing it this way, do it this way. It'll be easier every time. If you're not, then you need to do these multiple is not, and is not, and is not. So now we have another issue. We have the day. Now, I'm not going to go through every single month right now because it's 10/20. But you will need to understand that some months have 30 days and some months have 31 days, and February has 28 some years and 29 in others. Don't worry about that, about the February one. So I'm going to have to say if day is greater, I'm just going to say greater than 31, I'm going to print invalid. Okay, so that's my other validation. So a day can't be greater than 31, and a month has to be a valid month. Now what I'm going to do is, hold on, print, and then if month not in month, actually I want to do it like this, and day is greater than 31, then we're going to print invalid, else we're going to do everything else. So now inside the else statement, we're going to say, is my month in the spring, is my month in the summer, is my, when is this? So I know that March, April, May, and June are spring. So what I would say here is if month is March, or if month, is March, or month is April. Yes, what's the question? Ooh, so you can have branches inside other branches. Yes, you can. You can absolutely have branches inside other branches and loops inside other loops. So yes, you can. Or month is May, or month is June, and then, see, it's got to be March the 20th to June the 20th. So I'm going to say if the month is this, and you'll notice I just put parentheses around it, and I put parentheses around it because I want to treat that as a unit, okay? Because now I'm going to say, and day is greater than 19. Well, how is that? So if it's March, it has to be greater than the 20th. And if it's June, it has to be less. So actually, I'm not going to do that. I'm going to do this. And then I'm going to come down here, and I'm going to say if month is March, whoops, and day is greater than 19, or month is June, and day is less than or equal to 20, then I'm going to print spring. Otherwise, I got to do it all over again. So this would be how you would start Lab 3.12. You're going to take in the data. You're going to validate the input. So if you don't feel comfortable with lists, you're going to need this really long string to make sure that the month is not January or February or March. If you feel comfortable with lists, you just keep adding to this. And remember, cases and spaces matter. So you just add all of that to lists. And then the question is my input month in the list of months? True or false? True, I'm valid. False, I'm invalid. Is my day greater than 31? True, I'm valid. False, I'm invalid. Then you want to do everything else in the program because this is mutually exclusive. If either of these are not valid, you're going to print invalid and you don't want to do anything else. So the remainder of the code needs to be in the else statement. And inside the else statement, you can now segment it by season. So you know that March through June is spring. And you know that June 21st to September 21st is summer. So you can segment it like this. So first we look at the bigger scope, the month, and then we look at the day within the month. So you don't have to have an if statement for every month and every day combination. You just have to have the parts that matter. I don't know what that little emoji was, but okay. So for everyone who's left, who hasn't run screaming from the room because it's so late, are there any other questions? I got a syntax error saying it's not need to be not equal. Okay. All right. So this would also be, and it may just be that I'm using, okay, month, not in months, and day greater than 31. Where did you get the not equal part? Because is and is not should have worked. What line was that on? Okay. Luke, how about you do this as well? Just send me the code. And you and I can take a look at that as well, okay? Okay. So does anybody else have any questions? Because if not, I'm going to call it. I'll post the live coding session, and I will also post the scripts. No problem. You guys have a good evening, and barring any issues, we'll see you here again on Thursday. Good night, everybody.